Good. Welcome to the ARP course, week number 4. I think that you know already which is the contents of the next week, since probably you have read the slides, and you have seen that in the next week we will start analyzing one by one the concept analytically and in details when the contents of the syscalls, the basic syscalls in POSIX. So the chunks of code that you have seen and in which you've done some exercises was just to have the taste of the programs and of how the system calls operate, and to have an idea as well of the level of coding that is needed. But from now on we will take into account and we'll analyze also the codes that you have already seen, and we will see new codes. Some of them are inside the slides, and I hope it should be so. I hope that all codes can be simply copied and pasted into an editor and compiled and executed and run. So they are true exercises, but you will be asked to change the exercise and to write your own codes. And starting from this week, you will start coding for assignments. We will not evaluate the first assignments. Later, I will ask you to write something that will be also evaluated and will be part of the final mark in the course. So you know already the content of the classes next week. So what to do now? Well, we will talk again of the shell. We are really interested in the shell itself, the bash that is that you have in your Linux running. In particular, we are interested in the shell as a process, the POSIX process, with all characteristics of the process, just like I told you last week. So we can use the shell to also to investigate all the basic concept, the input-output process itself, how the shell runs new processes and executes new processes, how the shell uses channels for communication, the concept of the file that we will discuss this week, and how the communication channels can be connected to different processes, in particular different shells, and even how the shells manages the other communication primitive in POSIX, that is the event or signal in POSIX, as I told you. So these are the concepts we want to discuss, and at the same time, so we can also exercise ourselves in how to use the shell and in the many possibilities of the shell as a common language. So it's a textual interface with the system, and also as a programming language. We will not get into many details, but just a taste of the shell as a script language. In Aulaweb you have a short document with the basic commands, and we'll just we discuss we use those commands, and if it is the case, I will also suggest you to some changes on some parameters on how to use properly those commands with some additional information. If maybe there is something new to put in this document, so I will make a new release if it is the case. Remember that the shell is a programming language, so it's an interpreter for a script language. For example, this is, well, you see, this is a shell. The prompt of the shell by default to help you understand where you are is the complete path of the working directory in which you have the file. So I can have a look of the file. ls, the standard listing the directory. ls minus l is the extended directory in which we can see interesting information. Owner and group owner. This is a concept of basic security in Unix, Linux. So every file and every process has an owner. Here is the explicit name of the owner taken out from the database, in which owners are simply numbers, like a process ID, and the group to which the owner is one of the component. Groups are in another databases and so on. Other information: the number of bytes of the file, the creation, the last modification of the file. The three information on the file system are creation time, modification time, and access time. By default, this is the modification time. Last time we have made some changes in the file. And you see here rights. Rights, what does it mean? Read, write, and execute. RWX, RWX, RWX. Three, the why are repeated three times? Because the first array of modification. Well, what's the name? Well, let me stop a while. The name of capability that you have. These are capabilities for the owner. So Renato, that myself, is able to read, to write, and execute this file. Read, write, and execute. In this case, a.out is an executable file. So correctly, I have the possibility of executing the file. You see here that are source files, so are textual files. They have not the capability of executing because they can only be read and written by me. So I can change, can erase, can copy, can do anything. The second set is the capabilities by the group. In this case, the group has the same name of the owner, but it's just it's not it's by default is like that, but not necessarily. So the group has limited capabilities on this file, in particular only reading and executing if the file is executable. In that case, these are the default capabilities. And the third set is the what all other users are able to do with the files. That's called the others. So user, group, others. In general, these are the possibilities. So these are the files, and so we are seeing the ls. Other commands are classical. You see on the in the document, basic documents. Some names are old names are cryptical. For example, if you want to rename a file, you don't have the rename, you have the move. Move works both on files and on directories, because if we, at the end of the course, we have time to talk about the file system, the concept of basic file system, you will see that files and directories are the same thing at the low level. So why you move an object, which is a file or directory, you rename it. Copy is copy, and you can copy both directories and files. So in general, files and directories have no different treatment from the point of view of commands, so to act on them. So I was telling that the shell is first an executor of shell scripts. So single commands are a special case. For example, let's do an experiment. We write a shell script. Stop for a while. Okay, so clear, just to clear the window. While something, true is a command in the shell, or an executable, or the dummy executable that is always executes properly. While true, you see that the shell prompts you, because as with the while keyword is expecting that you go on in completing the while loop. So do echo, and we have to say something about echo because it seems a very simple or dumb command, but it's very important in debugging programs or writing shell scripts. Classical sleep for a while, for example 2 seconds, just to see that is a loop. Done. And you see the effect. While we have written done, we have completed the command that is a program, the loop, and is an endless loop. Okay. Okay, Control C. Control C we will talk later because it has to do with the capability of sending signals, so communication between processes. In that case, you are sending a signal by the keyboard to the process. The process is the shell itself, and it was executing a loop, has received the signal, and the signal is the signal number 9 that says, okay, stop what you're doing. Well, now we see that programs usually are not ask the shell. You do not ask the shell to execute interactively a program, a shell program, even if it is possible. Usually you store the program inside a file. Let's have a look to the one of the scripts. Yes, here ls-l. I have prepared some scripts, but usually are called scripts. First script, the .sh is just well, it's not compulsory, but it's common to write to remember that is a shell script. I will open using the old style. Oh well, first let me see what is inside. The cat, I think cat is not in your document, but cat is means concatenate and print in the standard output. We will see the standard output when we will see the different communication channels and the forking capabilities of the shell. We will see exactly why cat is commonly used. Concatenate and output. So if you have a short program or short file, you can use cat instead of less or more, since you don't need more screens than and so cat is faster, but is useful in the multi-process shell I will show you. So this is exactly what I've written interactively, and I can try to execute as a shell script. So what we have to do, like a.out, so in this directory, first script.sh, so execute. Haha, permesso negato, denied, permission denied. If I write without the sh, says not existing. What is this? Why? Because you see in the directory that is not executable. It should be executable exactly like a.out, because it's an executable file. So I have to change. I think that this command is not in the document, but I will write change modality, and there are several ways of using that. I just want to add the executable capability to myself. So the user add x first, automatic completion with tab. So if I do this -l, you see that first script now is executable for me, just for me, not for the group, not for all users. So I can write, and in this case the automatic completion works, tab, and so the script acts in the same way. Okay, so we have seen, we have learned how to write shell script and put into a file. Well, the capability of executing scripts or executing a language that is a sort of generalization of the C language. Well, it's not a generalization, and it's not true. Similar to the C language, but so little capabilities of describing types, but types are enriched with the values of the operating system. So files, processes, input-output channels, and many parameters or many values regarding the operating system. Limited capabilities of abstraction, of writing subroutines, but so it's a language that is, from a professional point of view, is very valuable because it is useful to write programs to deploy software. I think that most software deployed in a Unix environment is installed and distributed using shell programs that install that software on the particular machine, taking into account all the differences of the operating system, and so on. So in particular, since POSIX is a standard that guarantees you to write a program that can run in all machines, provided that you compile again in the target machine. Normally, POSIX programs are deployed using a shell program that installs on the particular machine, checking which are the capabilities, where are the standard libraries, and so on. So all the personalization of the POSIX program in a single machine is carried out by an installation software written normally in shell. Normally in shell, well, different dialects of the shell, bash or shell or corn shell or something like that. So this is another reason why I insist in showing you the basics of the shell and the knowledge of the existence of the shell. Well, since it is a programming language, it has variables. So what we can here see which are the special variables that you will, some of them, you will use some of them in debugging programs, even if you don't write shell programs, but just in the interactive command interpreter. Built-in variables with some special meaning. So we'll see now some of them. The most common and the most difficult to write in European keyboards is the tilde variable. I forgot to say that now we will use echo, the echo command, since the echo prints a value of a variable, and so you will see the value of some the variable using echo. So it's just not for saying hello world. So echo, and the first important variable is tilde. Try to find tilde in your keyboard. In American keyboards, international keyboards, usually it's easy to find. If you don't have the international keyboard, well, good luck. Which is the value of tilde? Tilde is the home directory. Home directory is not the current directory in general, well, is the login directory. When I run a shell, I am in my home directory. The home directory is the one in which I jump when I get use of the system, and is /home. That's Renato. /home is in Ubuntu distribution the standard directory which all users are. My name is Renato, and my home directory is this one. I can go to my home directory in this way. I will not list my directory. I can go back. Something that is not written there. So there is another variable that is minus, and just goes back to the previous directory. So to go back and forth, if you have two directories going back and forth, it's easy to do. The easiest way is not to mention the full path, but just to use this. Another command is push directory. If you have many directories, I use this one. So I'm back in home directory. I am pushing directories in a stack. I can go to / that is a root directory. So my stack is composed by actual directory, you see on the left, root directory. The previous one was my home directory, and then Dropbox, Dida, Rob, intro. And I go back with pop directories, pop D. Sorry. And now I'm back in. If I issue pop D, says stack the directory vuoto. Stack the directory vuoto in English accent. So empty stack, directory stack. So tilde is one of the it's important to move also inside shell scripts, but for debugging program and your program, take into account the following variables. The one is now has no meaning, but the dollar sign is the prefix. Is the prefix of many built-in variables just for controlling processes and so on. In that case, 0. You will see why. This is very important. When you ask the shell to fork and execute a process, maybe another shell or your own process, this variable holds the value, the return value of the exited process that you have run. So, for example, we have some process to a.out, but I don't remember what it is. Good hello.c. What does it do? It's just hello world, but with the exit 0. You see that usually what is by default the exiting value of a process. So remember that when a process exits, it returns to the fadder that did the fork running that process, fork and exec if it is the case, returns a value. In that case, it returns 0. That is considered the good value for the success exiting. So if I run, sorry, it writes hello world, and if I ask it says 0. If I compile this file, that simply exits with the value 1. And I say echo, you see the value 1. This is very important for debugging your processes. Don't forget, never forget to, if the process has several points in which it exits, the correct exit numbered with a numbered value. So to classify the point in which the process exits, the value may be negative. Usually negative values say error, but you can use in any case an integer number to define. And so you can, when you debug using the shell, you can have this value. Well, let's have a look to other 2 or 3 variables that can be very useful in debugging programs. One is a bit strange, that is, well, I always forget this because it's not so usual, but strange number, there is the answer. This is the process ID of the shell, in that case, of the process that has issued that. So if you have several shells, you can ask, which is my process ID? You see that all these variables have the counterpart in POSIX system calls that you will analyze. We will analyze together, and we will see. Not so important, but can be useful. And another is, we can see from this example, the third, I think I have the third example, the third script. First I have to make it executable. Change mod user execute third script. Okay, let's look at the third script. It's very simple. So echo a message, hi, but echo $$0 and sleep $1. So you have $$, $0, $1. We may have $2, $3, $4, and so on and so forth. This is exactly the shell counterpart of the standard C interface, argc, argv, so argument count and argument values, so the arrays of the parameters when you run a command. In that case, $sharp is the number of arguments. $0 is the name of the script, like argv0, which is the name of the command, of the executable, and $1 is the first good parameter, like argv1. So in that case, we know that we must run third script with one parameter. It is at least one parameter, because $1 is needed, and is used as the argument of sleep. So we assume that there are no loops here. We assume that the script runs, echoes those numbers of arguments and the name of the script, and that writes and waits for the seconds that you have written in and the parameter, and then exits with the value 2. This exit 2 is the same that we write in the program when you exit with a value. So it returns to the shell that have issued this command the value 2 that we can control. So let's run it. Two seconds delay. You see that there is one argument, but the echo was also the name of the shell, so the name of the executable, and that the shell of the shell script of the executable. And third, we can check the return value. That is 2, exactly 2. The return value is 2. So we see that we have all the mechanisms that are used in controlling execution and execution status, return, and so on. And now we have to spend a few minutes on the capabilities of forking, so of running new processes and making them communicate. So, using shell as a process manager, let's run the second script. Is similar to the previous one, the third script, but is in an endless loop. We specify a delay as a parameter 2, and this is the output. If you want to have a look, echo high, and the number of parameters and the name of the program itself, and then sleeps for the due time specified in the second parameter. The first thing we can do is just to use the special commands to send a message, to send an event, so a signal, a communication with no data content, but just an event, a software interrupt. And this is done using some keys in the keyboard that the drivers translate into signals. So if you we send I forgot just to say that there is another interesting variable that says, which is the history of all commands, if you are interested in that. history. So going back, execute this. Okay, this is loop. We can stop it by Ctrl Z, and you see fermato means stop it. Now we see that with the command jobs, we see that there is one job that is a process that is stopped because it received a signal, a special signal that simply stopped the process. So thinking of the switcher or the scheduler immediately puts the process in waiting state. Jobs is the list of jobs that are in so-called in background. We can restore the process, the job, with the syntax %1, because it's the only one, number one, and now it runs again in foreground, so interactively. We can stop and run in background. So in that case, BG sends a new signal, a new event, a new interrupt that takes the restore the running capabilities of the process. So the scheduler, it considers a normal process, but in that case it runs independently by the shell. So the shell now, you see, can execute commands. Sorry, it was the wrong command. We can clear the window and so on. So the shell is still active. ls-l, we can do everything, but of course we have a job running. If we say jobs, we see that is one executing in execution. That is called second script with parameter 2, ampersand, because ampersand is another way of directly making the process run in background. So now we must restore the, I don't know if I did, FG, okay. So with Ctrl C, I've just stopped it. Sorry, sometimes I mistyping. There is, if I ask jobs, you see there are no more jobs. So I can. The technique is to make the job one of the process. If we may have several processes in background, and we can let them run. And we have just one in foreground, the one to which we communicate. We can do the same. Well, the problem is that it's easier to do that. Second. Oh, sorry. Second script 3. Ampersand. Ampersand is the same thing, but runs directly in background the process. In that case, we have seen a scheme, and we will see again analyzing how the shell uses the system calls. The shell in that case forks and executes the second script, that is another process, without waiting for completion of the second script, of the second process, without waiting. So the mechanism is just to wait or not wait for the completion. So we say, if we ask, we have a process, a job, not a process, that is called job in the context of making them run in background and foreground. So I have job number 1 in execution in background. I can ask to go back in foreground, now you see that the shell does not respond anymore because it's waiting for the jobs. No more jobs. So this is a basic mechanism. So this explains how the shell can be used very easily to run several processes and to have the control of all of them. And another point that is really interesting is the redirection. We will learn in POSIX the concept of file, the abstract communication channel. The file can be a regular file, but may also be a communication channel between two processes or between the user and a process. In particular, there are standard the files in that case are we will see in the POSIX system calls as a number, an identifier, and is an integer number from 0 up to n, and when the operating system starts a shell, it defines three basic files. The three basic files are the three basic way of communicating with the process: number 0, number 1, number 2, and they are called standard input. Standard input is number 0, standard output is number 1, and standard error is number 2. Very important. Everything is written by an error system call, or the P error that we have already seen, that we will see more deeply. Every error message is written on the standard error file. By default, when you start a shell, so all processes that you run the first time have number 0, standard input, connected to the keyboard, number 1 connected to the window, to the active window, and number 2, error, connected to the same active window. So you have on the screen error messages, but are different communication channel. But you can define dynamically in a different way all those files, basic files. It is very important. For example, and the shell does, you will do in programming, the shell does using special syntactical constructs. For example, suppose you want to the cat gulalo.c. If you do cat is a process that reads the files, more than one. For example, also bad hello and first screen so many files, concatenate them and puts where? Not on the screen, on standard output that is connected by default to the screen. So if you do this, we see all the three files concatenated and printed. But you can decide that you redirect the number 1 file. For example, you can do cat, and the syntax, the shell syntax is this. We can you can decide that a P is a file name. If the file exists, it is erased and created from scratch. Otherwise, it is created and you don't see anything. But if you do cat P, we see the output. Redirecting the output means redirecting the file number 1 in that case. Short notation is directly, you can write directly this and so means 1. But if you want to be clear, you can write the number of the file descriptor, that is a communication channel. So all channels can be redirected, and it's very interesting. For example, you can redirect also the error like this. Let me do. If you run the second script, remember that the second script is a loop, endless loop, that echoes a message, hi, and the number of parameters and so on, then sleeps and does it again. But the sleep time is the second the parameter you issue. If you run directly, we know what happens. Number 2 seconds. So it's hi, the message, then the echoes of the parameters, and then a loop of 2 seconds. If we say simply, if you omit the number 2, if we have a look at the code, it should write the hi and the value of the parameter, but it fails in executing sleep. So the sleep during execution sends an error message saying that the value of the sleep is not possible, because probably is 0. So we see that it doesn't wait any delay time because we didn't specify, but you see here a lot of messages. So we have the hi, the value of the second script, the name of the script, the value 0, and sleep, operando mancante, the missing operand, and try sleep, help for more information. There is an error message. So we can do, for example, a thing like this. We can redirect the error on a file. This redirects only the error file. So there is an endless loop with no delay, but without error messages. If I succeed in stopping, and I see we can see the P file full of error messages. So I've demonstrated that we can separately redirect the channels that are defined inside the shell. You will use this mechanism to make processes communicate. In that case, the shell is a process that uses 2 channels and 3 channels including standard input, and I have redirected one of them in some other place, in that case into a file, but I can redirect also into another program. In that case, for example, let's issue a very long command, ls -l extended recursive root. So this is a complete listing of all files in the hard disk from root. So very long. It takes a lot of time and the output is very long. If I do that, you see, okay, I stopped with Ctrl C. But I can redirect the command. So the standard output of this, in that case, with this command, and you will learn how to do that in your process. The shell does and demonstrates how it works. But in that case, the semantics of the vertical bar, that is called pipe, is to connect the standard output. Standard output means the channel number 1. You can also redirect other channels, other file identifiers, but in that case you need some other syntax. By default, this is the standard output. You can redirect into the standard input of some other program, of some other process. So if I say so, more is a process that reads from standard input something and puts in just one page of your window, and you have to press space bar or return to go forward. And in that case, more reads from standard input. We know because it's a specification of more. And in that case, we redirect, we connect, we give a different meaning to the file descriptor 1 in output and the file descriptor 0 in input. And so that's the output. So we see just one page. Ancora is more, is the Italian translation for more. And if you do that, we can go on page by page or return just one. So this shows an Q for quit. This shows the all the mechanisms that we will learn, how to run different processes, how to run and wait, like in the shell in the foreground background mechanism, how to send events like the keys Ctrl C, Ctrl Z, how to send an event like foreground, so resume the stopped process in background that was waiting, and to make it go back and run, how to wait for the completion for a program, like issuing a command without the final ampersand in the shell, in case you say commands or process executable. Ampersand, you say, okay, run, but I don't wait and I go on. And how to redirect all the communication channels, or to set communication channel. The shell has already set standard input, standard output, and standard error, but can also decide that there are other communication channels, for example in the network. And you processes will inherit, you will see from the shell 0, 1 and 2, but you can change the meaning like we have done with the shell, with the redirection, or you can decide there are new communication channels. That is a general mechanism. So this is another important characteristic of the shell, just to show all the mechanisms of concurrency that can be used. And the shell is very useful in debugging because you can run separately the several processes that you will run all together and try to understand if they work in all their characteristics, the algorithm, the communication with other processes using what they are called channels, how they react to signals, and the shell is able to send signal and to receive signal and so on. So you can debug separately all the components, simulating all the communication between processes. Of course, this is not an exhaustive mechanism, but the first pass when you write a concurrent program is to debug each component, each sequential component, as much as possible by itself alone, by simulating using the shell all the interaction with other processes. Okay, we did a lot of I talked about much, probably too much, but I hope it is useful. Okay, have a nice Monday, and we will meet on Tuesday afternoon. Bye.